In this lesson, we're going to examine how to subtract radicals. We will look at understanding the common terms in radical expressions and then follow that with steps in subtracting radicals. So with common terms, you just have to make sure that the radicals have the same degree and they have the same radicand. The degree is going to be something like a square root or a cube root, and the radicand is the number under the square root sign. So we're going to look at square root of 18, and the method I like to use here is decomposing the radicand using the factor tree method. So that means for 18, we're going to end up with 2 and 9, and then 3 and 3. And for 8, we end up with 2 and 4, and then we end up with 2 and 2 for 4. So square root of 18, the way we're going to walk through this is we're going to group them in pairs. If you want some help trying to figure out how to convert or simplify a radical, you can take a look at the video titled Introducing Radicals. It has that in detail. So here we have a pair here because we're dealing with the square root. So this is going to give us 3 square root of 2. And for 8, we have a pair here. So this is going to give us 2 square root of 2. So you look at this right here, they're exactly the same, so we have common terms. Let's look at 27. 27 is 3 and 9, and then we have 3 and 3. Look at 32, we have 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. When you get more experience with working with radicals and the factor trees, you could most likely stop at 2 and 16 and realize that you have square root of 16 is 4, square root of 2, and then you can also stop here at 3 and 9, which is square root of 9 is 3. So we're going to have, because we have a pair here, we're going to have 3 square root of 3, and here we have 2 pairs right here. So we multiply 2 here and then 2 here. It's going to give us 4 square root of 2. So here you can see that the radicals are different, so that means that these two do not have common terms. Now let's try square root of cube root of 16. So the cube root of 16, we're going to use our factor trees again. We have 2, 8, 2, 4, 2, 2. Now for 32, we have 2 and 16. 16 breaks up into 2 and 8. 8 breaks up into 2 and 4. And 4 breaks up into 2 and 2. So the cube root of 16, so we have one group of 3. So that's going to give us 2. And then the cube root of 2. For 32, we have one group of 2's here, a group of 2's there. So that's going to give us 2 cube root of 4. Because your radical here are different, then that means that we do not have common terms. Now let's look at subtracting radicals. We want to examine common terms first. So these have common terms. So when they have common terms, you just subtract the coefficients. 7 minus 3, square root of 6. That's going to give us 4 square root of 6. In this case, we're going to simplify the radicals so that we can figure out what the radicand should be after simplifying the radicals. So we look at 12. We have 2 and 6, 2 and 3. So we have, for 27, we have 3 and 9, and then we have 3 and 3. So we're going to replace each of this with the new simplified we're going to replace them with simplified radicals. So 4 square root of 12 becomes 4 times 2 square root of 3 minus 27 is 3 square root of 3. So we have 8 square root of 3 minus 3 square root of 3. Because the radicals are the same here, we have common terms. So now we can have 8 minus 3 square root of 3, which is 5 square root of 3. So we're going to move over to this one, this question here, where we're going to simplify the radicals. So we start off with 50. We decompose that to 2 and 25. And then we have 5 and 5. Let's look at 45. We have 3 and 15, and then 3 and 5. And then 125, 5 and 25, and then we have 5 and 5. So 50 is 4 times 5 square root of 2. 45 is going to be 3 times 3 square root of 5. And then 125 is 5 square root of 5. So here's what we're going to do. Let's simplify this. We have 20 square root of 2 minus 9 square root of 5 minus 5 square root of 5. In this case, we can see here that these two right here, the 9 square root of 5 and 5 square root of 5, have common terms, so we can work with them. But this 20 square root of 2 doesn't have any common terms with the other ones, so we're going to leave it the same way. So this is going to be 20 square root of 2, and then here we have minus 9 minus 5 square root of 5. So this is 20 square root of 2 minus 14 square root of 5. Now over to this question here. Let's decompose 16 and 54. 16, we have 2 and 8, 2 and 4, and then we have 2 and 2, 4. Now look at 54. We have 2 and 27. 27 breaks up into 3 and 9, and 9 breaks up into 3 and 3. So we're going to now replace this with simplified radicals. So 2 cube root of 16 is going to give us 2 times 2 cube root of 2 minus 3 cube root of 2. So this is going to give us 4 cube root of 2 minus 3 cube root of 2. We're going to end up with 4 minus 3 cube root of 2, which is 1 cube root of 2, which actually ends up being exactly the same as the cube root of 2. Finally, let's look at this. We're going to apply the rules that we have learned so far with understanding the common terms and also simplifying the radicals. So this for 16, just based on what we've done before, this is going to give us 4 times 2 cube root of 2 minus 2 times 3 cube root of 2 minus 3 times 2 square root of 2 minus 5 times 4 square root of 2. So let's simplify. We have 8 cube root of 2 minus 6 cube root of 2 minus 6 square root of 2 minus 20 square root of 2. So let's group common terms together. So we have 8 minus 6 cube root of 2 minus 6 minus 20 square root of 2. So we have 2 cube root of 2 minus 26 square root of 2. Now you can see here a very important thing to note. Here we can see that the radicand are the same, but the degrees are different. So that makes these radicals very different, and so they do not have common terms.